Okay, so we're going to talk about 6.1 on our last unit here. There are two new rules that I need to teach you for us to be able to work through all of the problems for 6.1. And so the two rules are listed here. The first one you can see is this in the black ink. It says a number, which would be your x here, a number raised to a power times that same number raised to another power is the same thing as bringing that number straight over and then adding the exponents. And so the rule actually is if the bases are the same, so the whole big number, if they're exactly the same and it's a multiplication problem, you get to add the exponents. So here's an example of that. The problem actually is x squared times x to the 7th power. Since they are both x's, you bring the x over and then you add, since it was a multiplication problem, you get to add the exponents, so 2 plus 7. So my final answer is x to the 9th power. That's the first rule. The second rule is this example, and it says if x raised to a power, or a number raised to a power, is raised to a power. So let me show you this. Here's a base raised to a power, and then the parenthesis says everything inside this parenthesis is raised to this power. So it's a power raised to a power. Anytime that you have a power raised to a power, you will multiply the two powers together and keep your base. So here's an example. If I have x squared raised to the 7th power, so a power raised to a power, you're going to multiply those two numbers, and so 2 times 7 is 14, so x to the 14th is how I got my final answer. So these are the two rules that you need to write down, probably at the top of 6.1 and write rules. I would write the rule, I would write the example for both of these, and then you're going to use these two rules all the way through 6.1. 6.2, I'll teach you some new rules. 6.3, I'll teach you a few new rules. So if you want to actually create one page that is your rule page, and you can tell me what sections, you can write 6.1 rules, 6.2, but it'll all be on the same page. So you'll flip back to that page. Every time I give you some new rules in a lecture video, you'll flip back to that rule page and you'll write the rules down. I think that may be the best way for you to keep track of all of them. Okay, so let's go through a couple of examples here. So I'm not going to tell you what rule it is. We're going to write it up here, and you're going to have to start looking back at the rules that you wrote on your paper and deciding what kind of rule this is. Well, I don't see any exponents at all, so there's no new rule in this problem. But what I want you to know is that you are going to multiply the numbers together, because right, this is a multiplication problem. There's no add or subtract between these. These parentheses just touch, which means multiply. So this problem is actually -2 times c times 3 times d, right? Because these two are touching, which means multiply between it. The parentheses mean multiply, so everything is actually just separated by this multiplication dot. What I want to go together would be the numbers. So I have -2 times 3, and then the letters just go at the end. Okay? All right, so -2 times 3. 2 times 3 is 6. Signs are different. The answer is always negative, CD. So -6 CD is your final answer for this one. Now I want to point out, if you did not understand the rules in the last chapter, they're not going away. So you need to figure out that if it's a multiplication or a division problem, the signs are different, the answer is always negative. You need to start committing those rules to memory or holding onto them tightly so you can find them when you need them. The next problem is going to be 5x to the 3rd power times 4x to the 6th power. Okay, this is not a distribution problem because there is no add or subtract signs in this problem, okay? It is just a multiplication. So I want you to see that these can be separated back out just like we did in the last problem. 5 times x to the 3rd times 4 times x to the 6th. I know these two are going to go together, and I knew these two are going to go together, okay? In the last problem, I want you to see that one was C and one was D. So they just had to touch C and D beside each other. These two are both X's. So X is going to have a number up here after I'm finished applying one of those new rules to it. So let's start with the whole numbers first. 5 times 4 gives me 20. This is a multiplication problem, so we know that if the bases match, I get to add my exponents. So 3 plus 6 gives me 9. So 20x to the 9th power is my final answer. Okay. -2x to the 4th times 4x squared. Okay, there's no add or subtract signs separating any of these, so this is not a distribution problem from Unit 5. But what this is it's a multiplication problem between every one of these pieces. Okay, why do I know that? Because the parentheses are touching, which means multiply, and they're touching, which also means multiply is happening between them. So I know that I want to put my numbers together. 2 times 4 is 8. Signs are different, so the answer is always negative. And then these two, the bases match, right? They're both x. And since it's a multiplication problem and the bases match, I get to add my exponents. And so this becomes x to the 6th. So my final answer is negative 8x to the 6th. Okay. X to the 3rd times x to the 5th. The bases match, they are both x, right? The big number is both x, so x is a part of my answer. It's multiplication, so that means I'm going to add my exponents. So I have 3 plus 5. 3 plus 5 is 8, so x to the 8th is my final answer. There was no numbers in front, which means there's no numbers in front, okay? I can't make anything up. All right, I've got x squared raised to the 4th power. This one is different because x is squared. It's got a base of x and then it's squared, but that 4 doesn't have its own base. So let me show you the difference. Here it was x, right? It has a number, or a base has an exponent. A base has an exponent. This base has 2 exponents, okay? So that's why this one's different. So this is a power raised to a power. So when I have a power raised to a power is when I multiply my exponents. So my final answer is x to the 8th power. All right, y to the 4th power raised to the 3rd power. So is it rule 1 where they both have bases, it's a multiplication problem, and I add the exponents? Or is this a base raised to a power raised to a power? Right, it's the second one, so it's a power raised to a power. Why? Because this 3 does not have a y to go with it. They share one. When you see that happening, it's multiplication, so it's y 4 times 3, which is y to the 12th power is my final answer. Okay. I have 3x to the 4th. The whole thing is in parentheses and it's squared. All right, so let's scoot back just one. Inside parentheses, everything in there is raised to the 3rd power. Okay, the only thing in there is the y, right? It's the only base. In this one, everything in the parentheses is squared, but everything in the parentheses is actually this right here. Right? There's 2 things in the parentheses. So when you rewrite this to solve it, it actually belongs to both people. So when we solve this, we have 3 squared, which is 9, and a power raised to a power, so I multiply. So I have x 4 times 2, which is x to the 8th as my final answer. Okay. How did I know to do that? Because when I look at what's inside, it can be separated with a dot between it. I know that this guy on the outside belongs to everything inside. In this one, there's nothing to separate because that exponent belongs to that y. There's no other number in there. Okay, that's why these are different. Okay, I've got x to the 4th divided by 2, all raised to the 3rd power. So just like the last problem, everything in here gets squared because the parentheses told us so. In this problem, the parentheses are around this whole fraction here, so everything in there is raised to the 3rd power. So you can give it to both pieces inside. So when I rewrite this, it's now 4 x to the 4th raised to the 3rd power over 2 to the 3rd power. Okay? And so this is a power raised to a power. I know I'm going to multiply because this 3 up here does not have its own x to it. Okay, so 4 times 3 gives me 12 over, well, this right here is 2. It's what I see this many times. So 2 times 2 times 2. 2 times 2 is 4 Bring down the 2 you haven't used, and your answer is 8. So x to the 12th over 8 is my final answer. Okay. All right, so everything inside gets this third power. Everything inside looks like this when it's broken apart. And everything gets that cube, right? The 3, right? So the third power is being cubed. So -4 times -4 times -4. That's what you have right here. Signs are the same. The answer is positive. 4 times 4 is 16. Bring down what I haven't used. Signs are different. The answer is negative. 16 times 4 gives me 64. So this piece became -64. This piece, well, it's a power raised to a power, so I'm going to multiply my exponents, and I end up with x to the 6th. Final answer. Okay, last one. It's a little bit longer. Oops, sorry, let me give you a different color. Oops. And this one is 7x to the 6th times 2x to the 5th times 3x to the 4th. Okay, this is not a power raised to a power, right? Because every exponent has a base that it's touching. There's no extra one that doesn't have something belonging to it. So I can actually take all of the parentheses away and separate every single piece with a dot, a multiplication dot. So here's what we have. 7 times x to the 6th times 2 times x to the 5th times 3 times x to the 4th. So just looking at this, I know that I need to multiply all of the numbers, and then I need to multiply all of the x's with the exponents by following each of those rules. So I'm going to show you by dragging them down that I'm going to put these together. So 7 times 2 times 3, there's all my whole numbers, and then the x's are going to go later, and it's times x to the 6th times x to the 5th times x to the 4th. So 7 times 2 is 14. 14 times 3 is going to give me, I don't know, 42. So my numbers have all been multiplied together, and I got 42. Now I'm ready to deal with these guys. And so all of the bases all match. So I know that x is going to be part of my answer. It is a multiplication problem, so I'm going to add all of my exponents. So 6 plus 5 plus 4. Well, 6 plus 5 gives me 11, plus 4 gives me 15. So 42x to the 15th. I did not mean to leave a gap in here. It's all just touching. It's all straight together. So it's 42x to the 15th is my final answer. Okay. So we've just got to work on combining and multiplying numbers and raising powers to powers, the new rules that I've taught you. So work through your homework. Make sure you do your Toyos, and let me know if you have any questions.